Yeah, welcome to my talk about our journal paper, Joint Distributed Travel Time and Full Waveform Tomography for Enhanced Subsurface Imaging in Seismic Networks. My name is Ban-Sok Shin, and I'm from the Institute of Communications and Navigation at the German Aerospace Center. Let me first start with a short motivation of our work. Our goal is here to image the near surface on Mars and Moon, because here we expect to have cavities or lava tubes that might serve as safe habitats for future space exploration missions. Furthermore, we want to extract geological features and structures in order to understand these plans in more detail. Our vision to obtain this goal is to use a robotic swarm that conducts a seismic exploration in autonomous fashion. On the right-hand side here you can see an illustration of our concept. We have here multiple agents that are connected over wireless links with each other, so they can exchange data. And we have one agent that performs or acts as a seismic source. So here we inject waves into the ground, we measure the reflected and refracted waves on the surface. Based on these measurements, the rovers are to cooperatively image the subsurface. In order to realize such a system, we require distributed imaging for the subsurface exploration. So here our goal is then to obtain a subsurface image at each rover locally through data exchange with the direct neighbors of the respective rover. When we have a local image available at each rover, we can then use this image in order to adapt the topology of our seismic network in order to enhance maybe certain features in the subsurface image. What we proposed in this paper was a joint distributed imaging scheme that enables high resolution distributed imaging starting from a simple initial model. So to this end, we have, for example, here we start with a simple a velocity model of the subsurface that we want to reconstruct. Each receiver here has the same starting model, and then we apply the so-called D-TOMO method. This method is based on Traveltime tomography and obtains a low-resolution subsurface image at each receiver in a distributed fashion. After that, we apply the ATC-FWI, which is based on the full waveform inversion, which then obtains high-resolution subsurface images using the low-resolution subsurface images obtained by D-TOMO. So here we then obtain subsurface images again at each receiver locally via data exchange in the network with higher resolution. Here's a numerical result where we image the SEG EAGE sort model, which you can see here. And we have 24 receivers in a line array on the top, where each receiver has a maximum of 6 neighbors. So each receiver can communicate with 6 other receivers. As a source, we use a 20 Hz Richter wavelet, and we have 20 shot positions. Then we use D-TOMO for 10 iterations, where we have this starting model here, so a simple starting model. And after that, we use ATC-FWI for 15 iterations. Here you see the results for D-TOMO over 3 different receivers in the line array, and as a reference, the central result that would be obtained if we have all Traveltime data available at the central node. You can see that we have that the results coincide very well with the centralized result, and that they resemble also with each other over different receivers. Using these results, we can initialize ATC-FWI and then get these results at different receivers. You can also see that these coincide very well with the centralized result, but that they also slightly differ depending on which receiver we consider. So for example, receiver 1 here, and you see that the right-hand side has a lower resolution or is less accurate than compared to receiver 18, which sits in the center of the line array. As a conclusion, we proposed a joint distributed imaging scheme which obtains high resolution subsurface images starting from a simple initial model. And the scheme is fully distributed. That means that each receiver obtains an image locally via cooperation, and we are flexible in the network topology, so we do not require any full mesh topology or any anchor nodes. Our proposed scheme serves as the foundation for autonomous multi-agent seismic exploration. And if you have any further questions, please feel free to contact me. I'm happy to answer any questions. Thank you very much.